and welcome back to day 2. So we're continuing the little stretch through what I've called my opening 10 questions. Again, to be clear, these are genuinely the questions my A-level group will be doing this week. I found they challenge them a little bit and they highlight the sort of things or the sort of holes they may have in their knowledge. So first one seems fairly straightforward. Make sure you've answered both bit of the questions. Back in a second. All right, so 2 things to this question. The first thing is it a solve question. It is not a find the values of x or find the values of y. It is solve as in find x and find y. And secondly, it's a sketch question. So I specifically want you to have a go at sketching. So I'm actually going to start with the sketching. So if I look at equation 1, well, that's y equals x squared plus x. I know that's a quadratic because it's x squared. I know it's a happy or an upward sloping quadratic because it's a positive x squared. And so all I really need to do is think about where the vertex is. And the way I'm going to do that is I'm going to sketch that by completing the square. Half of x is half x. So therefore I can write this as x plus a half all squared minus a quarter. And that tells me my vertex is going to be minus a half minus a quarter. And so therefore I can do my sketch. Now I'm just going to put it up in one go and talk about it. So I know I've got the parabola. I know my vertex is minus a half minus a quarter. I think I'm missing a minus there, but there should be a minus a half there. And I also know that the straight line y equals minus 2x plus 4 goes through the point 4 and has a gradient minus 2. Again, this will not be a precise sketch. But what it does do is it then shows me that I understand roughly that this point here is going to be closer to the axis at this point here. Just give me a little bit of help as to how this might look. Let's get to the algebra. So the algebra is not too bad at all. It's not dissimilar to a sort of mid-ranking, hardish GCSE question. I'm going to rearrange equation 2. And so that's going to give me y equals 4 minus 2x. I'll call that equation 3. Now, equation 1 is y equals, equation 3 is y equals, so I'll just set these 2 equations equal to each other, rearrange to give me a quadratic. I notice that I've got minus 4 and minus 3, so which number is positive? So it's going to be positive 4 and minus 3, which gives me the completed factorised form, which means therefore x equals 1 or x equals minus 4. Again, remembering I haven't finished the question yet. So the question says, what are the values of y as well? So I'm going to go back to equation 3. So if x equals 1, y equals 4 minus 2, which is 2. So that gives me y equals 2. And if x equals minus 4, 4 minus 2 times minus 4 is 4 plus 8, which is going to be 12. Now, always play it safe here. I would argue I've linked up my x values and my y values. Make it super clear. I would actually put these as coordinates. So the first one is 1, 2. And the second one is minus 4, 12. What I would then do is actually write these on the graph just to fully answer the question, just to be safe, but either way, I've definitely solved the equation. That is question 1 of 2 done for today. Question 2. Okay, so this is one of those questions that either you're just going to get, or you're going to stare at and wonder about for quite a long time. So on the face of it, it's not a terrible question. It's not that difficult, but it does involve you realizing something. Now, if you've watched any of my other videos, what I'm about to say now is not going to be a surprise. You've got a question which has some index values in, and you've got a 2 and you've got a 48 and a 6. Let's think about the prime factors of 48. So 48 is 16 times 3, and 16 is 2 to the power of 4. So therefore it's 2 to the power of 4 times 3. And 6 is 2 times 3. So actually this question feels an awful lot like it's about 2s and 3s. If I could convert everything to 2s and 3s, well, then I could probably do some comparisons. So let's try and do that. So let's start with the really obvious thing. 2a is already in terms of 2, or base 2, so therefore I can write that as 2 to the power of a. Then thinking about the number 6, so the number of 6 is 2 times 3, so I could say 6 to the power of b is the same as 2 times 3 to the power of b. And therefore I could break out my brackets, which will give me 2b times 3 to the power of b. And then I could write, instead of writing 6 to the b, I could therefore write that's the same as 2 to the power of b times 3 to the power of b. Good. As discussed already, so 48 is 16 times 3, so that's 2 to the power of 4 times 3 to the power of 1. And I've done all the hard work for the question. Now suddenly the question is not too bad at all, is it? Because just by inspection, and by the way, the words by inspection, great words to use in an exam. It shows that you can just say, I've looked at it and these are clearly the answers. 3 to the power of b equals 3 to the power of 1, so it must be the case that b equals 1. And then I can see using my index rules, A plus B is equal to 4. I know B is equal to 1, so therefore A is equal to 3. Just write it underneath just for neatness for the examiner, and that is today's question done. As ever, any comments below, do leave a like on the video and do subscribe to the channel. We're going to do another few of these until the end of the week. The last two are much harder, so definitely make sure you tune in for the last two questions. Thanks all, bye.